Welcome to Spring LIB.
Okay, so the question is, which of these reactions is not stereospecific? We're shown trans 2-butene with Br2, right? So that's a double bond with Br2. We know that's stereospecific because when we add Br2 across a double bond, what we get is two bromines added anti across the double bond. That is stereospecific. The relationship between the two groups added is anti. Next, we see cis-2-pentene. I'm not drawing the full cis-2-pentene, but I'm saying it's a double bond with Br2 and water. Again, stereospecific because one side of the double bond gets a bromine, the other side gets an alcohol, but they are always added anti to each other. That is stereospecificity. And the next is trans 2-hexene with HBr. That is, it's some alkene with HBr. Okay, and this is not stereospecific. This is, in fact, the answer. And the reason for that is that we simply get bromine added to one side of that double bond, and in particular, we get bromine added to either side. Really, it depends. And that's because the reaction proceeds via a carbocation intermediate. So we can actually look at the mechanism for this reaction real quick and say, okay, double bond swings open to grab bromine. Like so. We get a carbocation on one side of the double bond, and then our Br minus then attacks that carbocation. But this attack from bromine can happen on the top or bottom face of our planar carbocation, which means we're going to get both in equal proportion, right? And that's why 3, the answer, is not stereospecific. We can quickly run through 4 and 5. Again, 4, we have an alkene. Doesn't really matter what it looks like. We're adding D2, which is, it's like hydrogen gas, but with deuterium instead on palladium. And we know, again, this adds deuterium atoms to the same face of the double bond. Okay, so that's stereospecificity. These are syn to each other. And then finally, we have MCPBA on some alkene. Okay, and this turns an alkene into an epoxide, and in particular, it's a bond to oxygen, which again are both on the same face of what was previously the alkene. Okay, so these are all 1, 2, 4, and 5 are all examples of multiple atoms being added to the same or opposite faces of an alkene, whereas number 3 adds a single atom that can pop up on either face somewhat arbitrarily of what was previously the alkene because it proceeds via a carbocation intermediate.